Hello students, in this video lecture series we will discuss all these cases. We will draw shear force diagram and bending moment diagram for each case. So, cases are, first is cantilever beam subjected to a concentrated load at free end. Cantilever beam subjected to uniformly distributed load over entire span. Cantilever beam subjected to uniformly varying load over entire span. After that, second is simply supported beam subjected to a concentrated load. Simply supported beam subjected to uniformly distributed load over entire span. Simply supported beam subjected to uniformly varying load over entire span. Simply supported beam subjected to an external movement. Third is overhanging beam subjected to a concentrated load at free end. So, in this video we will discuss first case, cantilever beam subjected to a concentrated load at free end. Now, we will solve this question. This is a cantilever beam, AB is a cantilever beam and weight W is applying at the free end. Length of the cantilever beam is L. Before starting this numerical, we will understand the sign conventions. So, these are the sign conventions. The shear force is positive if it tends to move left portion upward relative to right portion. Suppose this is a marker and applying force from left side upward like this and it is downward. So, it is left portion and it is right portion and it is written here the shear force is positive if it tends to move left portion upward. So, left portion is going upward. So, we will consider shear force as positive in this case. If it opposite like this one, it is going like this. So, we will take negative shear force. This is for the bending moment. The bending moment is positive if it tries to sag the beam. So, this is a beam which is sagging. So, bending moment will be positive. It is sagging bending moment. And if it is hogging, it is a negative bending moment. Again we will see the bending moment is positive if it try to sag the beam. So, beam is sagging, that is why it is positive. If left portion of the beam is considered positive movement, work out to be clockwise. So, it is clockwise, that is why it is a positive bending moment. Now, we will solve this question. This is a cantilever beam of length L and weight W is applying at the free end. So, what we will do? We will take section between A and B. This is a section and we are saying it y dash and distance of this section from the free end is x. Now, we will see force toward the left side of this section and I will slide this section to this side just near to A and we will see there is force W if the section is at this point. So, what will happen? X will reduce, this section will come to this side and at the left side of this section we are seeing force W which is downward. So, we will draw shear force diagram here A, B and when the section is at this position at the left of this force is W which is downward. So, it is downward, it is minus W. Now, we will slide this section to this side. Suppose at this position, if we will see towards the left of this side, there is force W. If section is moved to this portion, then force is W. So, there is no change in force. So, it will come like this straight line. So, this is shear force diagram. Shear force diagram. Shear force equal to minus W. Shear force at x equal to 0 is minus W, and shear force at x equal to L is minus W. Is it clear? Okay, we will see once more again. This is a section, and if we will slide this section to this side, so x will reduce, and at the left of this section, what is force? W, which is downward. So, this is downward. Now, I am sliding this section to this side. If it is at this position, at that time at the left side force is minus W. So, it is minus W. When this section will slide to this position, x will increase and it will become L. So, at the left of this there is only one force, which is minus W. So, force is constant over the entire span for the entire length. Now, we will write for the bending moment diagram. First, we will write the general equation of the bending moment. Bending moment equal to force, which is W into x. We can see here, this is a section which is at a distance of x from the free end. So, bending moment is force into perpendicular distance from this section. Force is minus W because it is downward, and it is the distance from this section. So, bending moment at x equal to 0. If I will slide this section to this side, so what will happen? X will reduce and it will decrease. So, it is the general equation. If I will put x equal to 0, bending moment is coming 0. If I put x equal to 0 in this equation, so bending moment will be 0. Means this section is sliding towards this and x is reducing to 0. So, bending moment is 0. Now, I will slide this section to this side. So, what will happen? X will increase, and when this section will come to this side at the end, x will become to L. So, bending moment at x equal to L is minus WL. In this equation, I will put x equal to L. So, I will get minus WL. So, what we are doing? We are sliding this section to this side and x is increasing and it is becoming equal to L. So, bending moment equation is this one, and we will get minus WL. So, at starting, when this section was at this point, x is 0, at that point bending moment is 0. So, bending moment is 0, and at the end it is minus WL. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So, we know this point it is 0, it is minus WL, and we know it is a linear equation. So, this is a linear equation, we will get a straight line. This is bending moment diagram. Is it clear? So, this was the case for the cantilever beam subjected to point load at the free end. In next video, we will discuss about the second case, which is cantilever beam subjected to uniformly distributed load over the entire span. Thank you.